Here's a program that goes wrong in a different way. We're going to fork in the main process. The child process is going to go to a loop, continually sending sig alarm to the parent process. Remember, get PPID gets the parent process's ID. The parent process, meanwhile, is going to sit in a loop, just printing out a floating point number that's counting up. When sig alarm is received, we'll just print out that we got an alarm. There's no shared variables that you see here, so it seems like it should be okay. Let's try running this program, though. I'll call it alarm.c. And we'll compile it. And you see numbers counting up are being printed out. You see some breaks where got alarm is being printed out. And then suddenly the whole thing freezes. Why would the whole thing freeze? The answer is that printf is not async signal safe. But async signal safe is a promise that it's okay to call a function in a signal handler. Printf is not async signal safe, and in particular, probably internally printf takes a lock because it's supposed to be multi-threaded safe, or something like that. In any case, you're not allowed to call printf from a signal handler, and if you do, bad things happen. Arbitrary bad things. What's the solution? The solution is not to call printf. That's why I was using SIO functions before. SIO stands for signal IO. It only calls signal IO put s, as supplied by csapp.c, only calls kernel functions that are declared to be async signal safe. If you want to know which functions are async signal safe, there's a list in the book, or you can do man7 signal and look for the async signal safe section. It gives you a list of all the kernel functions that you are allowed to call in a signal handler. There are many of them, but you may have noticed, if I scroll back a little bit, that printf was not in that list.